Okay, so let's do a little VLSM, variable length subnet masking. The steps I've got here for you: first, we need to rearrange our host needs from the largest to the smallest. Then we add 2 to the host needs to account for our network ID and the broadcast. We then write out the base subnet mask. Step 4 says to reserve enough host bits to account for our needed hosts. Step 5, turn on all the bits to the left of the reserved host bits, as they are now considered network bits. Step 6, find the last network bit, the one to the far right, and determine its bit positional value. Step 7, add this bit positional value to the current network to determine where the next network starts. Step 8, count the number of networking bits to determine the subnet mask for the current network you're working on. And finally, Step 9 says we repeat this process starting back up at Step 3, where we write out the base subnet mask again and continue on down through the steps. So let's take this example over here to the right. We've got our base network 192.168.0.0 and a base subnet mask of a /24. The first thing we're going to do is rearrange our host needs from largest to smallest. So we'll start out with 100, then we'll move to 20, then 12, and finally 2. The second step, add 2 to the host needs to account for our network ID and our broadcast. So we'll do that real quick. 102, 22, and it's good to go ahead and do this before you start reserving host bits, else you're liable to not reserve enough host bits. Okay? Now the next step, we start with our very first network here and we write out our base subnet mask. Our base subnet mask is this /24. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there's our network bits. We got to finish it out. 25, 26, 27, 28, 29, 30, 31, 32. Those are our host bits. Now we're trying to reserve enough host bits to give us at least 102 unique combinations of these zeros and ones to make up for those address needs that we need. Okay? So if I reserve 1 host bit, that gives me 2 unique combinations, a 0 or a 1. That's 2 addresses. If I reserve 2 host bits, that gives us 4 unique combinations, a 0 and a 0, a 0 and a 1 and a 0, or a 1 and a 1. Right? So if I reserve 2 host bits, that gives me 4 addresses. Okay? If I reserve 3 host bits, that gives me 8 addresses. If I reserve 4, that's 16. If I reserve 5, that's 32. If I reserve 6, that's 64. If I reserve 7, that's 128. So I can make 128 unique combinations of zeros and ones here, and that would account for 128 addresses, 126 of which could be host addresses. Okay? So I've reserved enough to give me at least 102 host needs. I can't hit 102 perfectly because we're dealing with binary here. So the best I can do is to reserve enough that will give me 128. Okay? Now, the next step, turn all the bits on to the left of the reserved host bits. So we just reserved all of these as host bits. So we draw us a line and everything to the left of that line gets turned on. It becomes a network bit. Okay? Now we find the last network bit and determine its bit positional value. So remember, when we're talking about bit positional values, if you take an octet, 1, 2, 3, 4, 5, 6, 7, 8, the first bit positional value, this bit right here, is 128. This one is 64, this one's 32, this one's 16, this one is 8, this one's 4, this one is 2, and this is 1. We're talking about bit positional values now. Okay? So this one occurs in the first octet, in the first bit position. So its bit positional value is 128, and this represents the range of our current network. But what we can do is take that range and add it to our current network to get to our next network. And we just add whatever the bit positional value is on the octet where it occurs. In this case, it's occurring on the 4th octet. So for this very first network, we're starting, they've given us our start, 192.168.0.0. So we know that 192.168.0.0 is where this first network starts. Now we can figure out where does the next network start based on the bit positional value that we just found and the octet where it occurs. So we can just add that bit positional value on that particular octet to get to the next network. So 192.168.0.0 plus 128 tells me where the next network occurs. Now we can work our way backwards to get to the broadcast address for this current network that we're on, 192.168.0, and we take 1 away from wherever the octet is where that last network bit occurs. And in this case, it occurred in the 4th octet, so we take 1 away from the 4th octet, which gives us 127, right? That's our broadcast for this current network we're on. And now we just count our network bits up. 8 plus another 8 gives me 16, plus another 8 gives me 24, and there is the 25th bit, and that gives us our subnet mask for the current network we're on. So we added the bit positional value to get to the next network. We counted the number of network bits to determine the subnet mask for the current network. Now we just repeat this process for the remaining network needs that we have, starting with writing out the base subnet mask again. So we come back to our base, which is a 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay? Now this time we're reserving enough to give us at least 22. If I reserve 1, that's 2. If I reserve 2, that's 4, 8, 16, 32. So there's our host bits that we have to reserve, right? And to the left of this line now, we turn everything on. Now we solve for the bit positional value of that last bit. And in this case, the first bit's a 128, 64. The third bit is a 32, and that's our range. Now we can just add 32 on the 4th octet to get to the next network. 192.168.0. 128 plus 32 gives us 160. Work our way backwards from that to get to the broadcast for our current network we're on, 192.168.0. Take 1 away from 160, we get 159. Count up our network bits for our current network subnet mask. That's 8, 16, 24, 25, 26, 27. And there's our subnet mask, 27. Now we just go back to step 3, write out our base subnet mask. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. This time we're solving for 14. There's 2, 4, 8, 16. That's enough. We draw our line. Everything to the left gets turned on. Solve for our bit positional value. In this case, it's the first one's 128, 64, 32. So it's a 16 this time. There's our range to next. We add 16 on the 4th octet again, 192, and that tells us where this next network starts. So 16 plus 160 is a 176. Work our way 1 backwards to get to the broadcast for the current network we're on, 192.168.0.175. Count up our network bits for our current network, 8, 16, 24, 25, 26, 27, 28. There's our subnet mask. Now we're back to step 3 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. This time we're solving for 4. Reserve 1 gives me 2. Reserve 2 gives me 4. There's my line. Turn everything to the left of that on. Find the bit positional value for that last one that we have turned on. In this case, it is a 4. Right? And even though we don't have a next network, we can just go ahead and write it down. So we're just adding 4 this time on the 4th octet again. Right? So the next network would start at 192.168.0. 4 plus 176 would give me 180. Now I can find out what the broadcast is for the current network I'm on. 192.168.0.179. Count my network bits. 8, 16, 24, 25, 26, 27, 28, 29, 30. And there is my subnet mask. And we're done. Here you have the base of 192.168.0.0 with a /20. Okay, there's your base. If I can get my pen to work. There we go. Rearrange our host needs from smallest to largest. And you may want to pause this video and work this out for yourself and then hit play again to make sure that you do this correctly. But I'm going to do it for you real quick. So the first one is 200. The next one is 115. The next one is 20. And finally we have 2. Alright, so we've rearranged. Now we're going to add 2. Okay, we've done that. Now we're going to write out our base subnet mask. So our base this time is a /20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. This time we're reserving enough host bits, so we've written out our base subnet. We're now on step 4 to account for host bits to account for 202 addresses. So if we start here at the far right, reserve 1 bit, that gives us 2. 2 bits gives us 4, 8, 16, 32, 64, 128, 256, and that's enough. So we draw our line, everything to the left gets turned on. Then we've reserved our host bits. We've turned all the bits on to the left as they are now network bits. Now we need to find the last network bit and determine its bit positional value. Here's the last network bit. Its bit positional value in this case, since it is the last bit in that octet, is a 1. And it's on the 3rd octet. Okay, so on our first network, we write out our base network that we started with, and that's 192.168.0.0. Now that we have the bit positional value of a 1 and we know it's on the 3rd octet, we add a 1 here to the 3rd octet to get to our next network. So our next network would start at 192.168.1.0. Now we can work backwards. 192.168. Take 1 away from where the last network bit occurs to get to the broadcast for the previous network. So 1 away from 1 is 0, and then everything else, if you have more octets, if you take 1 away from zeros, that would be 255. So that's our broadcast for this network. Now we just count our network bits that are network bits, 8, 16, 24, and that gives us our subnet mask for this next network. Now we've done all of those steps, and we want to repeat the process starting at step 3. So for this next network, we write back out our base of 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. This time we're reserving for 117. So if I reserve one bit, that's 2, 4, 8, 16, 34, or excuse me, 32, 64, 128, right? And that's enough. 128 gives us what we need. So everything to the left of that gets turned on. We find our bit positional value, and in this case it's a 128, and that's a range of this network. And remember though, this has moved to the 4th octet, right? So when we add this time to get to our next network, we're adding 128, but we're doing it on the 4th octet. So 192.168.1.0 plus 128. That's our next network. We can now work backwards. 192.168.1, take 1 away from the 4th octet, gives us a 127. That's our broadcast. Now we can count our network bits. 8, 16, 24, 25. This has a /25 as its network subnet mask. Now we just go back and repeat the process. Write out your base subnet of a /20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Right? This time we're solving for 22. So if I reserve 1, that's 2, 4, 8, 16, 32. That gives us enough. I draw my line. Everything to the left gets turned into network bits. Now I solve for what is the bit positional value of that last or least significant network bit. 128, 64. In this case, it's a 32. That's my range. It's on the 4th octet. So I can come down to figure out my next network. I just add 32 on the 4th octet. 192.168.1, 128 plus 32 is 160. Right? Now I can work my way backwards to get the broadcast for this network, and that would be 192.168.1.159. And that's my broadcast. And now I count my network bits. 8, 16, 24, 25, 26, 27. And there's my subnet mask. Now we go back and repeat the process for this final network. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. This time I'm solving for 4. I reserve 1, 2 host bits. That gives me 4. That's enough. Everything to the left gets turned on. Find the bit positional value of the last bit. In this case it is a 4, and it's on the 4th octet. So even though we don't have another one, I can just go ahead and do my calculation. 160 plus 4 gives me 164. Now this is the next network that we don't have actually, but we need that so that we can figure out what the broadcast is for this one that we're working on. 163, there's my broadcast. And then I just count my network bits. 8, 16, 24, 25, 26, 27, 28, 29, 30. And there is my subnet mask. Alright, let's do one more. So you may want to pause. So this time we're working with a base. 172.18.0.0 is where we're starting, and we have a base subnet mask of a /18. So the first step, rearrange our host needs from largest to smallest. So we have a 500, we have a 200, we have 128, and finally we have 4. All right. The next step, add 2 hosts to each of our host needs to account for the network ID and the broadcast. So we'll do that real quick. 502, 202, 130, 6. Okay? And we have to do that because if we don't do that, we may wind up not reserving enough host bits to account for the net ID and the broadcast. So we should go ahead and do that, add that addition of 2 right away. Next thing we do for the first network, we write our base subnet mask. In this case, we're working with an 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Those are the network bits. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. We're finding for 502. So if we reserve that first one, that's 2, 4, 8, 16, 32, 64, 128, 256, 512. 512 gives us enough. We can draw our line. Everything to the left gets turned on because it is now network bits. Okay, so we reserved our host bits, turn all the bits on to the left, find the last network bit and determine its bit positional value. This is the last network bit, its bit positional value. If we start from the left and work our way right, that's 128, 64, 32, 16, 8, 4, 2. So it's a 2, and it's on the 3rd octet. So we write our first network starts at our base. So we're going to write our first network. It's 172.18.0.0. Now we're going to add 2, right, on the 3rd octet to get to the next network. So the next network will start at 172.18.2.0. Okay? Now we can work our way 1 back to get to the broadcast for this network, the one we're working on. And if we don't take away from the first 2 octets, we take away wherever the last network bit occurs. In this case, it occurs in the 3rd octet. So we take 1 away from 2 to give us a 1, and then we take 1 away from everything else to the right of that. So that gives us 255. That's our broadcast. Now we count our network bits: 8, 16, 17, 18, 19, 20, 21, 22, 23. And there is our subnet mask. Now we go back to our base to work on our next network. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. This time we're solving for 202. There's 2, 4, 8, 16, 32, 64, 128, 256. So our demarcation line winds up right there on that octet, but we just keep following suit and we turn everything to the left of that line on to be network bits, right? Then we find our least significant network bit, and its bit positional value in this case equals a 1, and that's our range, and it's on the 3rd octet. So we just come down here and we add a 1 to the 3rd octet from this network to get to the next network. So 172.18.3.0 is where our next network starts. We can now figure out the broadcast for the network we're working on. 172.18, and we take 1 away from the 3rd octet because that's where the change is occurring at. So .2, and then 1 away from all of the octets to the right of that. Now we count our bits: 8, 16, and this time it's 24 network bits. So there's our subnet mask. Now we just go back and write out our base for this next network again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. This time we're solving for 130, 2, 4, 8, 16, 32, 64, 128. That's not enough. We need to reserve that last bit to give us 256. So it just so happens it works out to be the bit positional value of the least significant network bit is in the same place again. So BPV equals 1. That's our range. So we add 1 on the third octet to get to the next network. Work our way backwards to get to this network's broadcast. We take 1 away from the third octet and 1 away from everything else. Then we count up our network bits, 8, 16, 24, and there is our subnet mask for that one as well. Okay, and finally we're down to the very last one, but just remember, just go back to your base. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. This time we're solving for 6. Reserve 1, that's 2, 4, and we need to reserve 1 more to get to 8. Draw our line. Everything to the left gets turned on as network bits now. And we find the bit positional value. In this case, it's a 128, 64, 32, 16. It's an 8 this time. Right? There's our range. And even though we don't have a next network, we're just going to add 8 to the fourth octet so that we keep ourselves correct. 172.18.4.8 is where the next network that we're not solving for, but we need to find that so that we can very easily find the broadcast for the network we are working on. Right? That's the broadcast for this network. And then we count our network bits. 8, 16, 24, 25, 26, 27, 28, 29 /29. And there you have it. I hope that helps. Practice, practice, practice. That's what you have to do. But after a while, it becomes second nature. Good luck.